In these next two, there is a little bit more going on here, but really not a lot. Notice how I've X'd out the part where it says assume the variable being solved for is greater than 0. We may have formulas where the variable we're solving for could be positive or negative. You may get directions that say leave the plus minus sign there. Just don't know. Okay, so after squaring k on this first one, it's multiplied by 9 and by pi. We could view this instead of two separate things as the 9 pi, they're grouped together, multiplied to the k squared after we've done the 9 times the pi. So think of that whole thing as a coefficient for k squared. I'm going to divide both sides by k squared. So k squared equals 9 times r over 9 pi. Apply the square root property to cancel the squaring on the left, plus or minus k over 9 pi's square root. We don't want fractions underneath a radical, nor do we want radicals in a denominator. I can simplify the square to 9, but I'm going to have to multiply top and bottom, similar to that last example in the last video, by square root of pi. And so we'll have plus or minus square root of k times square root of pi. I'll put together as a single radical, all over 3 pi. And on number 5 here, something similar is going to come up at the end, but first, what we're solving for is in the denominator of a fraction. We know how to get rid of that. Multiply both sides by k squared, so that we don't have a fraction anymore. Well, then, since the k squared is multiplied by g, similar to k squared being multiplied by 9 pi over here, k squared equals ma all over g. And to get a little more space, I'm going to apply the square root property. Plus or minus, once I put in that plus minus this time, it's not going to disappear. So k is equal to plus or minus square root of ma over g. And if I multiply top and bottom by the g inside the square root, it's going to give me mag all over g squared underneath that square root. Since all of those are to the first power in the numerator, I'm not going to be able to simplify any of that, but g squared, taking the square root of that, will just give me g. So k is equal to plus or minus square root of mag all over a g outside of the radical.